All right, let's talk about galvanic or voltaic cells first. So two names, same thing. So galvanic or voltaic cells involve a spontaneous redox reaction. That means they just happen on their own. And galvanic or voltaic cells are batteries. So that's kind of a good thing, because if they had to be forced, then what's the point of a battery? In the diagram of an electrochemical cell that's voltaic or galvanic, you may see a voltmeter. Okay, now it may be labeled voltmeter like it is in these two, or it may just be a symbol like this. Okay, you will absolutely not see a battery. It is a battery. A battery doesn't have a battery, okay? So a battery sometimes will say the word battery, or it will use this symbol. The battery's found in the wire. So if you see something like that, that tells you, this is not galvanic or voltaic. In this type of cell, the energy change goes from chemical to electrical. So it's using chemical energy stored in that cell to produce electricity. We have to have a salt bridge. And the salt bridge allows ions to flow back and forth and keeps the cell neutral. So do you see right here, this is the salt bridge. You can see the ions flowing back and forth. Here is the salt bridge, which allows the ions to flow back and forth. It needs a wire. Well, we have to have electricity, so we need a wire. And the electrons are going to flow through the wire. And the electrons always flow from anode to cathode. So they flow in alphabetical order. They flow from anode to cathode in alphabetical order. All right, let's talk about the anode first. It has a charge of negative, like an anion. It is having oxidation happen. Remember that anox phrase? And then since it's oxidation, think Leo, it loses electrons. And when it's losing, the electrons are on the product side. Because remember, if we draw a quick sketch of a number line, Leo goes this way, okay? So also, if you look at this half reaction, which is here, you can see the electrons on the product side at the anode, which has oxidation, has a negative charge. Okay. Also, you could see this, electrons flowing through the wire. What would be moving through the salt bridge? You would have ions going back and forth to keep it neutral. Now, since the anode is losing electrons, the mass, the size of it is going to get smaller. If the size is getting smaller, sometimes they word it this way. That means the number of atoms is decreasing, but the number of ions is increasing. So in this example right here, zinc is not disappearing. The zinc is changing from an atom to an ion in the solution. So at the anode, the number of atoms decreases because the piece gets little, but the ions increases in the solution. Okay. On table J, the anode is going to be higher. So higher is oxidation. All right, let's look at the cathode. The cathode has the charge of positive, like a cation. If you think of red cat, reduction happens here. And since it's reduction, we think GR, it gains electrons. And if you remember the number line, real quick like this, the GR arrow went like this. So the electrons are on the reactant side. And if we look at our half reaction right here, you can see that electrons are indeed on the reactant side. So cathode reduction has a positive charge. Okay. Now, since the cathode is gaining electrons, so here's our Cu cathode, right? It is getting bigger. Okay. If it's getting bigger, the number of atoms increases because the atoms are on the piece of the metal. And the number of ions will be decreasing. So they're coming out of the solution and out of ions and becoming atoms, and then the piece gets bigger. Okay. On table J, the cathode metal will be lower on table J. All right, now we're going to do a few examples. Here's the first one, but I'm going to write it out on paper instead of doing my chicken scratch on the screen.
All right, here we go. So it says use the diagram of the electrochemical cell to answer these questions. Before I answer the questions, I am going to label every single thing I possibly can on this diagram. Okay, so first, how can I tell this is what kind of electrochemical cell? You see the voltmeter, so that means we are voltaic or galvanic. All right, what are my two metals? Well, I have copper and I have lead. All right, so let's look at table J and let's find copper down here. Where's lead? Okay, still at the bottom, but lead is higher. When we have a galvanic cell, the higher metal will be oxidized. So this one is oxidized. So this one is reduced. If it is oxidized, remember anox. So this is the anode. So this is the cathode. Since it's voltaic or galvanic, the anode is negative and the cathode is positive. Okay. Electrons will flow through the wire from anode to cathode. So electrons are going to go this way. All right. What goes through the salt bridge? We have ions, right? They're going to keep the cell neutral. Let's see, since this is the anode, right, and that's oxidation, so that's losing electrons. This side is gaining electrons. Since it's losing electrons, the mass goes down. This mass would go up, which means mass is atoms. Those are the same thing. Okay, and then ions would go down. Okay, and then this side it would go up because that's the opposite. Okay. Here's our equation. So again, this one is oxidized and this one is reduced because remember it has to be on the reactant side. All right. Okay, so let's see. That should be enough to answer all the questions. When the switch is closed, which electrode will become heavier? Well, I did figure that out. This one, the mass is decreasing right here. So copper. Which direction will electrons flow? Well, I did figure that out. It went from PB to Cu. See this? It doesn't, electrons, first of all, do not go through the salt bridge. So it is from PB to Cu. Which metal will be oxidized? Look, I wrote it down here. PB without the charge. See what it looks like here? And what is the purpose of the salt bridge? So allow ions to flow back and forth. I could say to keep the cell electrically neutral. But there you go. That's the first one.
All right, here's the next one, but on paper.
Okay, this one, base your answers to this diagram. So I've got some questions. So before I even get to the questions, I'm going to label everything I possibly can in this diagram. First, you see this, that's a voltmeter. So that means I have a voltaic or a galvanic cell. All right, now I have two metals, Cu and Zn. Let's go to table J. And let's see, here's Cu, where's Zn? Up here. So Zn is higher. If Zn is higher, it is oxidized. So that means copper is reduced. So remember anox. So this is the anode and this is the cathode. The cathode has a positive charge. In a voltaic galvanic cell, the anode is negative. Let's see, what else do I know? Oxidation means losing electrons. This means gaining electrons. So in this one, since it's losing electrons, the mass goes down, which means atoms goes down. But ions, which means what ends up in the solution, goes up because it's moving from mass to ion. And then on this side, we have mass going up because we're gaining electrons, and atom going up. And then those are coming out of solution, so the ions are going down. Remember, in the salt bridge, we have ions flowing back and forth, and we have electrons through the wire from anode to cathode. All right, let's look at the questions now. They should be easy peasy. Label the anode and the cathode. Label the direction of electron flow. Psst, already did. What charge does the cathode have? Positive. What is happening to the size of the zinc electrode? Oh, well, the mass is, it's going down, it's decreasing. And why? Because it is losing electrons. So atoms are losing electrons and becoming ions. Write a balanced equation for the oxidation half reaction. Okay, so oxidation, I have zinc. So I have zinc, and then look right here, it tells me this. I have Zn plus 2. All right, so if it's oxidation, right, I'm losing electrons. What is happening? And the mass is decreasing. So that means I'm starting with zinc like this, and it is becoming a zinc ion, but I need electrons. So you could draw a quick number line, although I'm not sure you need to. This is Leo this way. That would be Ger, but again, I'm only looking at oxidation, right? From 0 to 2, I move 2 hops. That's 2 electrons. And you can see how it's following Leo. Now, is it balanced in atoms? Yes. In charge, 0 plus 2 and negative 2, 0. So this is my answer for that. And there you go.
Here's the next one, again on paper.
All right, so here's another one. I've got some questions, but let's try and label everything I possibly can in the picture before I even get to the questions. So because I see a voltmeter, I know this is voltaic or galvanic, right? I have 2 metals at the electrodes, Mg and Zn. Let's find them on table J. Well, Mg is right here, Zn is here. So which one is higher? Mg. So that means Mg is oxidized. So that means this is reduced. Whichever is oxidized is the anode, and that is negative. So this is the cathode, and that is positive. All right, the anode, anox, right? But oxidation means loss of electrons, so that's losing electrons. This one is gaining electrons. So if it's losing electrons, mass goes down, atoms goes down, because that's the same thing. That's the piece. So that means the ions must be going up. And on the other side, since it's gaining electrons, the mass, which is what is made of atoms, is increasing. And the ions coming out of solution are decreasing. Let's see, what goes through the salt bridge? Ions. What goes through the wire? Electrons. From anode to cathode. So in this direction. Okay, so let's see. Label the cathode, done. Label the anode, done. Write the half reaction which occurs at the anode. So the anode is oxidation. So let's see, here's a little quick number line. And I have Mg and I have Mg plus 2. All right, so if this piece is getting smaller, then I'm starting with Mg and going to Mg plus 2, right? So if I'm going this way, that is definitely following Leo. How many jumps? 2. So the electrons go on this side, right, when Leo points this way, or when we move on the number line, it points that way. So atoms balance, yes. Charges balance, plus 2 and negative 2 is 0. Perfect. Label and show the direction of the movement of electrons. I did direction, and it's labeled with electron. So there you go. That's that one.
All right, here's our last example, again on paper.
Okay, so here's a whole bunch. I got to label a whole bunch. So let's see what I can figure out without even looking at the question, right? This is a voltmeter, so that means I have a voltaic or a galvanic cell. All right, let's look at my two metals. I have nickel and I have barium. So on this table, here's barium, here's nickel. Okay, so barium is higher. So barium will be oxidized. That means nickel will be reduced. Anox. So this is the anode. It's negative. This is positive. And the cathode. Oxidation means LEO, right? So that's lose electrons. So if it's losing electrons, that piece of metal is going to get smaller. The number of atoms in that piece of metal will get smaller, but the ions in solution will go up on this side. Since it's reduction, that is GER, that is gaining electrons. Since it's gaining electrons, the mass of that piece of metal will go up, which means the atoms will go up because the atoms are on the piece of metal. The ions will go down. What will happen here is ions will flow back and forth. Electrons will flow through the wire from anode to cathode. Okay. All right, so let's see. Label the anode, done. Label the cathode, done. Label the positive electrode and the negative electrode, done. Direction of electron flow, done. Direction of anion flow. Well, I said ions, but we'll say anions. They would go both ways, right? And the salt bridge. So this is the salt bridge. Okay. Now, according to table J, which will go undergo oxidation? Well, the one that is getting smaller, so barium, right? Which will undergo reduction if it gains. It's not going to be the solid piece because remember the number of ions are decreasing, so it's going to be what's in solution. So that's the nickel, but the nickel ion. So kind of what you can always remember is the one that undergoes oxidation is the atom on this side when it is the anode, and it will be the ion for the cathode. Okay, so that's it.
And that is galvanic or voltaic cells, or as you know them, batteries. I hope you learned something new today.